So today we're going to kind of build on what we've been doing, reminding ourselves if you have questions, ask them. So we're going to do substitutions. You're saying, "Ooh, yay, that's exciting. I know how to do that." But my problem's going to look a little different. So I'm going to say solve for your variables, and here is your system. Okay. So we have this beautiful system, but usually we only have two equations with two variables. Now we have three equations with three variables, and we're saying, oh man, this is definitely going to be more work. But once again, it's the idea of the concept of substitution. If you understand that concept, hopefully you'll be able to follow. If you can't follow, please let me know, and I will help you. So we have these three things, and it's asking for substitution. So I'll kind of break it down by step for substitution, and then we'll do elimination later. So the first step one, we're going to choose an equation to isolate the variable. Because with substitution, we want one variable. Oh my gosh, what is going on with my voice right now? Excuse me. We want one variable to be isolated so we can actually substitute in for it. So kind of look, try to find the easiest one. I'm not going to rearrange this first equation, that looks annoying. I'm going to do the second equation because this x doesn't have a coefficient. So I always kind of look for that. I find that to be the easiest. So I'm going to take this equation and let's isolate x. Okay, so we've done that 7 million times. You kind of just take something, you rearrange it because you want a variable by itself. Are there any questions on step one? Step two. We're going to substitute into the two other equations. Okay. So I have two other equations that I haven't dealt with yet. The first one was 2x plus 3y minus 2z equals negative 1. Oops, that's a negative 1. And then I have the other one, 4z minus 5x equals 4. So I'm going to take what I know, and that's that x is equal to negative 5y plus 9. I'm going to substitute into both of them. So let's do it with the first one. So we're going to do 2, but x is getting replaced with negative 5y plus 9. And then we have plus 3y minus 2z equals negative 1. I'm going to do a little simplifying just while I'm here. We might as well kind of clean this up a little. We're going to distribute in. I can't write today. I don't know what's wrong with Tuesday. I'm going to combine like terms as well. And I'll kind of go from there. I'm going to put things in standard form too. So negative 10 and 3y is going to give me negative 7y. I'm going to put the 2z next, and I'm just going to move this constant to the other side, just so my constants are together. So that's looking a little better already, just kind of moving a few things. Okay, so we have one equation. Now we're going to substitute to the second equation. You can see a lot of the steps we've been doing. We're just having to do it a few times. Now for x, I'm replacing it with negative 5y plus 9. 4. And I'm going to simplify that a little just to make it a little bit nicer. And I'm going to kind of put things in standard form too. So in standard form, I'll put the y first, then the z, and I'm going to move this 45 to this side. Oops. Okay. Now once again, I would never give you a ton of these to do at once because they're kind of annoying. Or they're not annoying, they're just a little bit longer. Okay. So now we have two equations with two variables. So that basically brings us back to what we've been doing, which is solving a system using substitution or elimination. So step 3, Solve the system using either method. And kind of go from there. So when I say solve the system, I mean these two equations. I'll kind of line them up. Sorry, I know I'm in the way. I'm going to move in a second here. I just want to write this first. All right. So basically my main goal is to kind of try to substitute in so then we get down to two variables, because once we have two variables, we know how to solve that. So from here, you can use either method. So why don't you do that part? You guys should be able to. That's good practice. Are we okay? The number should be a little nicer, so you should feel a little bit better about life, hopefully. But if I just said, can you solve that system? You go ahead and see what you get. Sorry to the person watching. So once again, I know that that assignment was a little aggressive. Hopefully this is not as bad. Your number should come out to a nice integer. Just make sure you're okay with the concept. I'm just gonna kind of solve as you guys are solving. I'm gonna put this by 2. Oops. Oh, a minute. So as you're solving, hopefully that wasn't too terrible because the z's weren't that bad to cancel. I just multiplied the first equation by 2, eliminated my z's, solved, and y came out to 1, so I'm feeling pretty good about life. So step 4, I'm just gonna kind of switch it in down here. Step 4 is just find all variables by plugging in into equations. So basically I'm just gonna work my way back so I can get x, y, and z. Right now I have y. So I can find z by plugging into one of these equations, the ones I found there. So pick one, it doesn't really matter. I really can't stand here. So I'll pick the first one. I know I'm in the way. I'll try not to write over here anymore. I'm just gonna tell you the answer. Z should have been 6. And then I kind of work my way back, because I need x. So I'll just plug it into this equation, because I have x equals -5 times a 1 plus a 9. X is going to equal 4. So my final answer would be 4, 1, 6. So you just write it as x, y, z. One of the days, I forget which day, you're going to do a little visualizing, because right now we're used to 2 dimensions, x and y. We're adding this third dimension of z, which means we're actually graphing 3-dimensionally. But we might not be able to actually visualize what that looks like. So you're going to do like a little computer thing over at the end of the week. So you can kind of see what the heck are we actually finding. But we're just finding something in 3 dimensions. That's super fun. Okay. let's take a break. Here's my question to you. I'm gonna pause it. One button. Okay, let's do one elimination and then we'll wrap it up for today, and then tomorrow we'll just do a bunch of practice. So with elimination, kind of the same idea. We want to eliminate a variable. Unfortunately, we can't just do it kind of from right here. You have to split up and have pairs. So what I want to do as the first step, well, before I kind of start, I'm going to decide a variable I want to cancel. So I look at my coefficients. I have a 3, 2, 1, a 3, 1, 2, and a 6, 3, 1. I'm going to choose the z's to cancel just because it just makes sense to me because you won't have to multiply both. So pick two equations. So I'm going to pick the first one and the second one. So step one is pick two equations, eliminate a variable. I'm going to eliminate the z's we said. So I would multiply this by -2. If I kind of rewrite that. Sorry, I like to rewrite both. That would give me -4x minus 2y minus 6z equals -14. And now I'm going to combine them together. That would just give me -1x plus 1y, eliminate, equals 5, or equals -5, excuse me. Okay, so that wasn't terrible. You pick two, you decide. Now basically you do that same exact step, you just have to choose a different pair. So I'm gonna kind of just do it right below it. So down here, I'm gonna pick a different pair. So I chose equation 1 and 2. This time I'm gonna choose equation 2 and 3. Or you could do 1 and 3, it's really just preference. You just choose a different pair. So I'm gonna choose 2x plus y plus 3z equals 7. And then x plus 2y minus z equals -10. And I'm gonna just make sure on this step you eliminate the same variable, because if not, it's gonna be a big mess. So I'm gonna eliminate the z's again. I'll multiply this by 3. I like to kind of rewrite everything. And then I'm going to add them together. I get 5x plus 7y, those eliminate, equals -23. And the main reason I did that is now I'm going to take those two equations, line them up, and do regular elimination. So our main goal is always to kind of get it to a space where I already know how to do the problem. So I already know substitution and elimination with two variables. So we kind of just have to do that in between step, whether you want it to be that way or the substitution way. I think it really just a lot of times depends on what equations you have. But we've seen both types and we'll practice more with them tomorrow. But our main goal is to just solve this. I'm going to multiply this first equation by 5 to eliminate the x's. I'll just rewrite it right below. -5x plus 5y equals -25. When I add them, what do I get? Those would cancel. I get 12y equals -48. So y would be -4. Okay, that wasn't too bad once I kind of get to that part. And then you kind of just work your way back. So you plug that into an equation that has two variables to find the one you don't have. And then once you have two, you go back to one that has 3. So I'll pick that first equation, plug in my y, and solve for x. And then you kind of just come over here, pick one, it doesn't matter, whichever one's gonna float your boat here. I'm gonna pick the third one. So if I do x plus 2 times y, I'm looking for z. So that would be what, 1 minus 8, which would be -7, which would be z equals 3. So now that I got everything, I have my 3 variables, 1, -3. So once again, main goal, get it to a point where we know how to solve it. We know how to do everything with 2 variables, so you just have to do that kind of in-between step to go from 3 to 2.
I mean, those X, Y, Z.
Always, yeah. It's always alphabetical. So if you have like random A, B, C, it goes in that order. So I'll leave that up for a second. Once again, I know today we just saw one of these, so if you're still like a little iffy, that's okay. We have all of tomorrow to practice, ask questions, do whatever you gotta do. So as you leave for the week, basically the week is just kind of practicing this stuff, and none of the answers are too crazy, so you should be okay. But then having that extra day tomorrow, we'll just let you test out the different methods, see which ones you're liking more. A lot of it has to do with the setups. So if you see something,